Good afternoon. Thank you so much for joining me for this session. One thing to clear, first of all, this is a talk about serverless technology, not about Lego models and things. Obviously, we'll see a few Lego minifigures here and there, but it's more or less a cloud serverless technology talk. So I have packed agenda. So we'll start off with the introductions, and then I will go through what made us to get to serverless, and then I will be spending more time in terms of the lessons and the experiences learned that I think will be useful to you to take away, and then we'll close with when we use serverless, what we need to think of, for the future or going forward. So that's sort of the, idea for today. So my name is Sheen Brisals, and I work for the Lego Group, and I am active in the AWS and serverless community, so I have the privilege of known as a serverless hero. I write about serverless, talk about serverless around the world across different conferences. So this is front page of lego.com. Most of what I will be talking today relate to this particular website or the e-commerce side of lego.com. And to give you a context, so if you take Lego Group like any other big corporates, it's a big organization with different departments, and I come under a division called Marketing Channels Technology, which is part of the bigger the technology division, and MCT is kind of divided into subdomains, and each subdomain has number of product squads. So MCT is where predominantly all the customer-related technology activities happen. So the Lego.com, the retail store, the customer support center, all the technologies they use, and they all come under MCT. So that's sort of the domain that I will be presenting today. Equally, on the other parts of Lego, the Lego Group, across different departments and teams, various other technologies are used from on-prem hosted data centers onto containers, Kubernetes, all sorts of things. Okay, right. So let me start with some of the struggles we faced. So this is going back 2016, 2015 when we were running the legacy e-commerce platform. It was kind of powered by the typical JBoss application server, into different 8 servers and bunch of this, sort of technologies, Java, JSPs, and all sorts of things. But it went through some makeover, especially on the front-end side of things. I mean, those days, the releasing something to production was a big occasion. So we kind of split into 2 groups, and you go through this sort of, the ritual of draining and then kind of deploying and testing. And then releasing if everything went well. It takes nearly an hour or 2 for engineers to work together. If something went wrong, we need to go all the way back and start again. And because of these difficulties, the release to production was like once in 3 weeks or even months, especially when it comes close to the the typical Black Friday or the holiday season. Everything gets frozen and you can't touch the code until the next year. All sorts of these sort of things that we were kind of fighting against. It was going okay, but then we did some sort of a makeover. So we put, sort of a REST APIs in the front, but the back end still was a monolith fighting with a single database and all sorts of things. And the front end, we moved to cloud with AWS, Elastic Beanstalk and things. But then what happened was that one high season event or high occasion like Black Friday, things started to fail. So the back-end applications, one by one, started to give up, and that put more load on the ATG or the application server. That exhausted all its, threads and the connections and everything. And within few seconds, we didn't have a shop. Everything was down. So then by the time it came back after a few hours, then things, kind of died down, and we just lost the customers and things like that. But if you look at some of the failure points of that particular system. There are quite a few. I'm not going to go through all these kind of things. Some of these things you can easily relate, like single database or tightly coupled monolithic applications, on-prem and looked after by, the engineering team and things like that. So all these things were pain points identified at the back of this script. Not just one failure, we had, more than one failure on crucial occasions. So that kind of, triggered us to look for something better, something new or change, because business had ambitions. So they wanted to reach more children across different locales, and they wanted to get into more sort of observable or traceable environment for the business to see what's going on, and also the ability to kind of roll things into production in an incremental way rather than waiting for months or weeks before we push things to. So the idea was to come with a sort of the minimum viable product concept and take it to a maximum valuable product. So that's why I'm saying MVP to MVP, these sort of things. But it was inevitable to change, but there were so many options. Where do we start? Because if you are completely new to cloud and any of the modern technologies, your thinking always goes with what you already had, right? So the options were like, okay, shall we go to another vendor, or shall we stick with the existing vendor and use their sort of a cloud quoted the application, or shall we do something else? So microservices was in the thinking, and containers or running in containers and managing all the scaling and things. They're always part of thinking. But people are questioning, so if you're thinking of containers, isn't the same trouble that you tried to avoid when we were kind of managing with the hosted applications and things, the self-hosted. So serverless wasn't even in the thinking at that stage. Microservices was probably the most advanced thing. So at some point, the thought of serverless came through, like at the end of your eye, something is blinking. You keep ignoring, but it's still blinking. So few of us, we went through different conferences and read through articles and talked to people in the industry at that time. So this is like going back to 2017, 2018, early days of serverless and stuff. So we got some idea that this technology can work. We can make it work for this purpose. So that's where the starting. That's where it started. So in terms of starting, so if you are new to serverless, can you just raise your hand if you are completely new to serverless? Okay, fine. Yeah. So I'm not going to deep into serverless, but in terms of technology wise, it has many benefits, right? I mean, there are always debates around when to use serverless, when to use containers, but that's fine. But as far as serverless concerned, it has its own kind of benefits that you don't need to kind of manage your servers, and you just pay for what you use or what you store. Still, you're not kind of locked into having your containers running for long, etc., etc. But for me, the why we need serverless is more important than what we think of serverless. So because it's an ecosystem of many managed applications, not just function as a service or Lambda functions. That's an important aspect. The other thing is you can go down deeper when you optimize your microservices or services, because your microservices has bunch of Lambda functions or other resources. You can choose and target each and every one within your microservice to tune or optimize as per the need. And one of the other, the great things I like about serverless and the event-driven architecture is the way we can incrementally and iteratively bring things to production, so that, the olden days of weeks of waiting no longer there. And the most important aspect is it makes an engineering team more diverse. When I say that, because engineers these days are not just programmers. They no longer kind of receive architectural blueprints from somebody and then do it. They are are part of the system. They talk about architecture. They talk about security. They do programming. So that's what another benefit of serverless, because it brings so many other technologies into its whole ecosystem. That's a great benefit of serverless. So based on that, what we did was we just did a simple experiment. So we put a simple microservice, one API endpoint, and a Lambda function. All we did was the tax system at the end, which was a tightly coupled on-prem. We realized that the same vendor had a cloud version. So I thought, okay, let's use that and see if it works. And that was the first one we did. And, to everyone's surprise and amazement, it worked beautifully, and it stood strong on the next Black Friday and scaled automatically. It was kind of the eye opener. So from there on, things moved on faster because of the confidence that we got. So I always, talk about this because I like the first step we take, irrespective of the technology, whether it's serverless or something else new. It's always important that when we make a step, we try to improve, because when you adopt new technology, we're not going to make anything perfect, whether it's microservice or serverless or whatever. Okay, but the important thing is making a start and then getting better every time we iterate over. So that's where our serverless journey started. But thing was, we had a very shorter time frame to get the Lego.com moved over from the legacy platform. It was 10 months. So that's when, the speed of migration started. So the rich man once said, speed matters in business. Easy for him to say, but as engineering, teams we go through, that is our struggle. But we kind of, took the challenge on, and we kind of rolled out services after services every month. I'm not going to go through the architecture details, but the learnings that we learned. So initially we kind of started off with some sort of a strangler pattern or doing something in parallel. But then we realized that the serverless wasn't too bad. It was faster than the legacy system. So these sort of little learnings gave the confidence to try out more. So all sorts of patterns. So there was a talk earlier this morning about patterns. So typically when you go through these situations, you apply all those things. So we did the migration in two phases. The first phase we focused on all the backend, not non-customer facing services, because we didn't want to disrupt the customer. Then the second phase, with the confidence gained, then we kind of, moved all the front end or the customer facing into services into serverless. So, and then the power of cloud comes into play. So when you think of clickstream events from a busy website, you're thinking of millions of events coming in a minute. So we had technology, serverless technology. They were able to kind of help us with the ingestion and the processing of the events within seconds or minutes. So all these sort of the learnings that we went through, and there's so many things that I can kind of talk about. So every learning was new, and engineers were kind of rolling out new services and new architectural constructs every day, and sort of the pattern. So here you see the sort of the same pipeline being kind of used for various purposes. So these sort of the simple things that really helped us to move forward. And data migration, customer data migration, we took a bold step, because typically when you go through a migration project, you think of, okay, so here is millions of data record. So now we need to engage in some sort of a migration project, get all this data over here. So what we did was we thought, okay, let's not do that way, because many millions of customer data may be already kind of deadwood or useless, because customers moved on or created new accounts. So let's do an on-demand. So for that, we trusted the event-driven architecture. So as customers come to the news site first time, we do some sort of the back-end processing to pull data from different sources, including the legacy setup and SAP systems, over to the new platform. So this again worked beautifully. And then the checkout service, this was one of the crucial services, the part of the checkout flow. This is coming towards the user-facing flow. So these things happened. And then at the end of the 10 months, we moved over. So it was back in 2019. We switched the backend of Lego.com, completely over to serverless. And the architecture is simple. As a high-level architecture is simple. So you see these sort of the 3 layers here. So this is the back end, 100% serverless microservices, and you have the front end running on Fargate or containers, and there is in between the what we call the backend for front end. That's where the GraphQL layer, caching, all sorts of things take place. So, as I always say, especially with serverless, it takes a while to get off the ground because new technology, new way of thinking and doing things. But the good thing is, once you're up above and running, then it really becomes easier to keep going with the knowledge gains and the velocity you will have with your the team. Now, this was back in 2018 when we started the whole journey. And by the time we moved things over to serverless, we had typically two teams. So the back end and the front end split. And from there on, things changed. I'll talk about that, in a few slides. So now, if you think of the team structure, I think we have around 30 or so what we call the product squads, because we were able to kind of set up in a smaller scale, small team squad setup basis. That allows us to move faster because there's no crossover. Service communication is all well defined via APIs or events and things like that. Now, in terms of business growth, so many things happen. I mean, we stopped kind of talking about this nowadays because it's kind of boring these days. Though, early days, it was always kind of exciting to see, oh, how did it scale, or did we, stand up to the traffic and everything. And the sort of the typical spikes, if you are familiar with demanding systems, all kind of normal these days. Every month there is a new product launch, system goes through a bunch of these spikes. No one really cares unless there is a issue or issue with the deployment or something to look into. Okay, so that moves us to the important part, learnings. What did we learn, and what can I convey to anyone out there amongst you thinking of serverless, adopting serverless? The first thing is you should be able to accept change because certain technologies disrupt, okay? And we should be able to understand and accept the impact it's going to cause and then go with it. It's like, technology always evolves. Who is making it to evolve? Us. Because we demand more things. To satisfy our demand, the invention happens. So it's going in a cycle and cycle, moving faster and faster like a flywheel, right? So that's an important aspect to think that, okay, there are changes, there are different ways of doing things, so we should be able to prepare for it. So that's why I always say that we need to have that sort of mind shift or mindset change when we adopt or when we work with serverless. And as I mentioned, it requires a kind of new way of doing things. When I say new way of things, so typically the old waterfall model, it goes through different phases and gets to the maintenance phase, and that's it. That's the end of life. Then it gets into the sort of bug fixes and things like that. But these days, the products are sustained for longer, because we don't go for this sort of big bang approach. We go for the iterative and incremental way. So that is the change. And then it's not kind of once you're done and it's kind of dead forever. It's more alive because you keep adding. I mean, there was a talk earlier about evolving the architecture. So it evolves, okay, with the product and things. So you're making it sustainable going forward because the product needs to stay longer. So that's where I say that, the thinking needs to be different when we work with, the modern technologies, cloud, serverless, asynchronous, event-driven architecture, things like that. The second most important aspect is you should be able to think of domains. Now, domain-driven design, I think, is kind of mentioned all over the conference. Even today I saw the patents talk showing the book as well. Well, I usually joke about it because it's not a book. It's actually an industry. If you think of all the books that were written for people to understand this book, and all the conferences run, people pay thousands of dollars to understand this, It is an industry, so we should all thank Eric Evans for giving us the business opportunity here. But jokes aside, it teaches plenty of things. It teaches how to look at the business as domains, and how to distill or break down to the lower level, however you kind of structure subdomains, or coming down to the bounded context and having the boundaries and things like that. These are all important aspects that will kind of transition. You can take all these learnings into doing serverless as well. So that's where the power comes in. So to give you an example, say you have 5 domains. Okay, and then if you break down, you get into all the subdomains. I'm not going to name things, so just to give you the idea of how this can happen. And when you get to the subdomains, it becomes easier. You can easily identify your boundaries or the bounded context. Okay, for simplicity, I put one. So could be more than one within a subdomain, depending on how you kind of structured and drew your boundaries. Now, when you get to this level, it really easy to assign ownership. That's where the squads come in. The squads, the evolution I mentioned earlier, because now each boundary is owned by a small team, and they do their development, whether it is microservices or web applications, inside inside those boundaries. And this makes, if you want to scale up your team and structure, really helps. So because now the ownership is defined, the boundary is defined, that's where the APIs and events come into play, and they are loosely coupled or decoupled. So this is one of the important aspects. Now, it's easy for me to say, but for engineers, one of the biggest problems is how to break down a problem domain. They struggle because sometimes the monolith thinking still kind of lurks around. So I kind of use a sort of an analogy, and that is the set pieces analogy. Okay, so let me explain what I mean. So if you take a filmmaking or even a theater, for example, they don't do end to end in one go, right? Apart from the single short film or whatever, they do in pieces. Okay, so the shooting happens in pieces. Same thing in football. This is where I borrowed the term. There is something called set piece play. So that just foul happens and they just play. The scoring a goal or whatever. Same you can apply when you build models and toys. You can build in small pieces, bring them together. Same analogy if you can apply when you build microservices or break things down. So even in this case, when you break things down, you should be you can do all the things that you do in isolation before you take it to production. Say, for example, here is a payments bounded context. You can easily put that as a single microservice and set up your pipelines and things like that. But thing is, what happens if part of this particular service, the change frequency is more? Why do we need to then deploy everything all the time? So this is kind of the way of thinking as you break things down. Is there a way I can separate that part out and carve that as a smaller microservices so that if that changes, nothing else gets affected? So if you apply the sort of the breakdown, the set piece view, you can easily see that this payments, the subdomain or the bounded context can be easily broken down into bunch of smaller microservices. Okay, but the important point is they all sit within that boundary. That is important. Okay, so this is what the set piece analogy I kind of encourage engineers to look into. Now we have the independent deployment pipeline, so that engineers can work in isolation. They don't need to step on each other's toes and make a merge mess and things like that. So here is an example of a different bounded context. This is a loyalty service. So this is how it's kind of structured. Not exactly, what we have and now, but the idea of breaking down. If you look at the three services on the right-hand side, they're all talking to some external third-party applications, right? So if you're familiar with domain-driven design, this is a way of implementing the anti-corruption layer, because none of the other microservices get affected with the data structure and things like that. Right. So how do these things work together? Simple. It's event-driven architecture, right? Because if you take the examples I showed you earlier, how do they bring all the pieces of a film or theater together? They play music or they interludes and dialogues and things like that. So if you take the same approach to our architectural side of things, the microservices, they all come together via APIs, messages, events. And of course, they have patterns like orchestration or choreography. So all these kind of things come into play as part of the implementation and architectural thinking to make us kind of evolve in a smaller microservices way in serverless. Okay, and of course it uses proven patterns you saw, and this is another important aspect when we do serverless. Again, there was a talk on Gang of Four patterns book, and obviously things change with cloud and serverless. There are new patterns and new ways of doing, but there are certain patterns still, remain same. And things like orchestration and choreography, they play an important role in cloud or modern architecture or implementations. So when it comes to choreography, this is where the microservices come in. So choreography, as we all know, that the movements happen once you kind of teach. You don't need to instruct, because as per the music, the actions and things change. So this is how more like event-driven microservices way, because events get published, get subscribed, and when a service subscribes something, it knows what to do. You don't need to kind of instruct. So that's sort of the coordinating microservices using kind of the choreography, and this is a typical the PubSub model. Whereas when it comes to orchestration, there is always someone instructing or directing, right? So this is like the typical workflow, or if you are familiar with the AWS, there is this service called Step Functions, which acts as the orchestrator. And usually, it's better to keep the orchestration inside a microservice, because if you are reaching out to a resource in another microservice, that means you are building a tight coupling, right? So try to stick inside the microservice and orchestrate the services. But how do you kind of cross the boundary? So that's where we have something called the distributed orchestration. So again, the technologies differ, but in AWS, a step function, there is something called task tokens. You can send a token via event, and it can go to different microservices, and they can perform and submit the token back. So that when the token comes back, the original, the orchestration, then the flow will then carry on. So there are different ways to kind of, distribute. Another learning important one is building well-architected microservices. Now, well-architected framework is from AWS, but irrespective of the provider, we can apply the sort of concepts and the processes to everyone. So when I say building well-architected microservices, what I mean is like having the alarms, doing the sort of structured logging, and doing the observability thinking right from the beginning, not towards the end, and having the security mindset. And what we do is we do a process called a service audit. So that means if a team or engineer is ready to deploy a microservice or microservices to production, they need to go through a bunch of checklists to make sure that they kind of ticked all the boxes. Things like structured logging, have you set up your dashboard, or do you have alarm set up, and all sorts of things. The thing is, it may look kind of daunting at the beginning, but once they got going, it becomes just like tech, because it becomes part of their day-to-day kind of way of doing things. And solution design is another important phase that we promote. So solution design is where that, say, we are doing a new feature or a new microservice or a new implementation that will go through some sort of architectural thinking, whiteboarding, brainstorming, ideation, also all sorts of things. Then one or two engineers will take ownership of doing the design part. That's why I say we don't kind of supply architectural stuff to our engineers. We make them architect. We help them to do the architecture bit. So they go through this thing. They talk to the experts who can contribute or review and bounce ideas and learn, and then they present a solution design document to the team or their squad to review. And that's when kind of new ideas or debates and arguments, things will come, but things will get settled quickly, and only then they will then proceed to creating Jira tickets and start the typical implementation phase. One of the other things that we add as part of the solution design or as a separate activity is threat modeling. So this again depends on the nature of the application or the service. Sometimes a big application or a service requires its own threat modeling document, whereas in other cases it can be part of the solution design itself. So this is again another important area where it makes engineers to think. Okay, so these are the things they should be considering, because there are different approaches. We followed the stride, the methodology. So they go through so that they think when they kind of give permission to a function to access the data or put some sensitive information in the logs and things like that. So all part of the process, and that comes to the growing engineering teams. So I do a separate talk on this one, because when in serverless, it's so important that we grow engineers. That is the only way to grow the team and in turn the organization. If there is no growth of engineers, you can imagine that there is not much vibe going on. And for that, we need to provide them the environment. So environment in the sense that freedom they need to explore. Sometimes fail, they will fail, so they learn from the mistakes. So that's another beauty of small increments, because even if the failure happens, we can quickly revert and start again. So these are of the things, and then provide the opportunities for them to grow in terms of learning potential or conferences, blog posts. Nowadays, modern technology, there are so many things happening all the time. So it's all good to feed those things to engineers and encourage them to participate in, writing or conference talks or all sorts of community sharing, open source. All these things help to kind of put them in the right mindset and, grow. Needless to say that automation, DevOps is a thing, these days. I mean, it's given that everyone is kind of going through this sort of the process. It really helps. And the squad structure and the team ownership and things I mentioned. So especially when it comes to setting up the pipelines, deploying to prod and etc., it's all done by the team. It doesn't go to a separate DevOps team or some people like that. They will be there like platform teams and DevOps teams, but they are there to enable the other teams. So if you are familiar with the team topologies, this is like a enabling team versus the stream aligned team. So that's sort of the concept here. And so the service ownership I mentioned. And along with that, it also important depends on how you structure your cloud account and things. If at all possible, give each bounded context or the subdomain your own account, cloud account to operate. That brings a lot of benefits rather than just combining things into one account, then trying to separate out, because it allows with the freedom. So, for example, one particular team or squad can have a different environment for their operation or their APIs. So this is another important aspect. I mean, I'm pretty sure these days, nobody's operating with a single account that's for dev, QA, and prod. Hopefully not. But even when you have multiple teams, wherever possible, combine them and have a separate account, because there are so many things, the separation of all these things, plus the, service limits come into play, especially with the cloud, even if says, limitless scale, but there are limits. So it really helps we have sort of, the separate accounts and the separation. And development cycle, I mentioned that, you have to have that sort of mentality. This is your service. You own it. You take care of it. I mean, I'm here today, but I know that if something happened, the production, the product I'm responsible for, I'm sure the engineers will take care of that. That's sort of the confidence we need to slowly build into the team. For that, you need to kind of give them the opportunity, or make them aware. Things like solution design I mentioned. One of the areas in the solution design we ask them to do is, as they finish all the design details and things, identify what are the observability and monitoring needs this service needs to have. So they just need to write down, so that tickets will be created, and they can set up the dashboard, or they can kind of set up the metric queries and all sorts of things. So these are all the things, part of the serverless engineer's lifestyle. That's why I mentioned that there's kind of a diverse engineering team it brings. So I talked about the incremental approach and stuff. CI/CD pipeline, again, we use GitHub Actions these days, and it just goes through. And on top, what we have is most of the squads or teams have some kind of what we call the control center, where they know exactly what service is in which stage, environment, etc. From there, they can easily push things to production. And by the way, there's no kind of restriction these days. They can deploy to any day, including Friday afternoon, if they are confident. So, and alarms and alerts. So there are a bunch of Slack. No, we don't use Slack at the moment. Teams channels where they get streamed, the important ones. If something is burning in production, they will know immediately and jump in. And this is an example of one particular squad's dashboards. This is common across the number of squad. So moving on quickly onto the future. So serverless is an evolving technology. Cloud itself is an evolving technology. So many new things coming, AI, ChatGPT, all sorts. So how do we keep up? So simple things. So three things I already touched upon. Encourage the continuous learning and have this continuous refactoring mindset, and then of course growing teams, as I already mentioned. Continuous learning is like keep an eye on the things that are coming up, because as things evolve, cloud services are kind of being released almost every other day. Even serverless managed services coming along, new features all the time. So we should be kind of, updated, so that we can evaluate and identify which one to bring in and which one can wait for until next year and things like that. Because that's important when it comes to the continuous, the refactoring stage. Continuous improvement is an ongoing process. You should be kind of part of the process going forward. Now, good old days, it's been there for many, 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 many years, right? So from the early days of our development, from the procedural to object-oriented to, from now. But things change now. So if we go back, so those days, this used to be one of my favorite books. And but it had its purpose, but those days it was more object-oriented, based on those object-oriented constructs and the refactoring things. But these days change, but because we are kind of up against different way of doing things. So nowadays it's not just the program restructuring. We need to rewire the services, and we need to kind of look at certain infrastructure aspects and how we can make things better. So these things should be part of the thinking or the development process, especially when we work with the serverless and modern cloud. Refactoring is a kind of tricky term, because if you talk to business stakeholders, refactoring, they go all the way back to the mainframe to the other migration or refactoring, right? So their thinking is that way, because they will think that, oh, you guys are using modern technology, what are you talking about refactoring? Is it not the past? No. So that's why you need to kind of educate them to say that, you need to kind of teach in their language, because easy to kind of convince them in that way. Say, for example, if you're introducing a new API capability, what you can say is, you're refactoring to reduce the latency. But for business, you can say that, oh, it's going to give you, better net promoter score or customer satisfaction. Same way, if you are, if you are kind of now batch processing more messages because you are the cloud service you are using now capable of giving you more. You can say that, oh, by the way, so we can now serve more customers. So these are the ways you can easily kind of convince the business, and then keep it part of your the development process. So usually I talk to the product managers and buy some week sprint or two or couple of weeks every quarter to go through some of these refactoring aspects and identify and push the tickets through for the future implementation. um, so for engineers, it also helps because they're not kind of getting into the board state of refactoring again, because they will be interested because new services they are going to work with or introduce. So that kind of keeps them, motivated. So that's another thing. Right. So towards the end, takeaway points. I like this quote because we always talk a lot of, so many things all the time. But thing is, if you kept on thinking about something, it's not going to happen. We just need to do it, right? And also, the other thing is, we can all hear somebody else experience or someone explaining, oh, we did this way, that way, etc. But unless we go through it, it's not our experience. So you need to keep that in mind. So to wrap up, if you are thinking of adopting serverless, make a simple and humble start and grow from there. And that's the way you can identify any early mistakes and rectify before you are too far ahead and kind of it's impossible to come back. Now, having that mind shift, as I mentioned, is very important. You hear lots of people talking about this sort of mindset change or mindset shift when you work with serverless. That is crucial. And thinking of the granularity, breaking down your domain into the smaller part, and understanding the granularity of serverless. Like I mentioned, going down deep into every function level or every queue or table and tuning all sorts of things. That is a power, and then you can kind of benefit from that. And team, of course, you need to kind of keep them growing, so that the motivation there, the contribution, velocity, flow, etc. will be there as well. And finally, think of sustainability. I mean, I again do a different talk on serverless and sustainability, and people say that, okay, because of certain benefits, serverless already kind of enables sustainability, but there are so many ways we can kind of, as part of our development and cloud running, etc., we can promote. So that's all for today. Thank you so much for your listening. Thank you.